Hello students, welcome to the fourth module, second lecturing class. Okay. Last class we discussed about the definition of the mix design. We discussed about the what are the references for this mix design, and next what are the data required for the mix proportions. Next step-by-step procedure for a mix design. That is first to discuss about the target strength, how to determine the target strength by using two equations. Next, to discuss about the selection of a water cement ratio by using that graph, okay, and also by using table number 5 from the IS 456. Okay, and next to discuss about the air content. Next, to discuss about the water content and admixture content. Following that, next to discuss about the calculation of cement and cementitious material, how much quantity of cement is required, that we discussed. Next, finally we discussed estimation of the coarse aggregate, how much coarse aggregate is required for a mix proportions. Okay, and finally trial mixes. Okay, these are the points we discussed in the last class. That is mix proportions. Mix proportions is nothing but how much quantity of a coarse aggregate, a fine aggregate with respect to cement and with respect to a water content we need to add. That is, if you are going to mix it for 1:2, 2:3, that 1 represent a 1% or 1 bag of cement. Okay, a 2 represents a fine aggregate and 3 represents a coarse aggregate. If you are taking 1 bag of cement, that is 50 kg of cement, 2 means 50 into 2, that is 100 kg of fine aggregate you need to add. 3 means 50 into 3 means 150 kg of a coarse aggregate you need to add. That is 1:2, 2:3. 1 is 50 kg, that is cement, 100 kg of fine aggregate, and 150 kg of coarse aggregate you need to add with respect to whatever the water content, water cement ratio you are keeping. Okay, based on that, you need to obtain that ratio. That obtaining that ratio, or calling it as a mix proportions or a mix design it is. Okay, that one is given by our IS code, that is 10262 2019. Okay, this is latest code, revised codes in 2019. Earlier we used to 2009 code. Okay, after 10 years it is revised. Uh, in Annexa A, that is in IS code itself, it is given some examples of the mix proportions. In Annexa A, we will discuss a problems, okay, that designed for a M40 grade of the concrete. Okay, in IS code only, the problem that given in IS code that we discuss. Okay, these are the data given for a mixed design purpose. Okay, our proportions for a concrete to get a minimum strength of 40 Newton per mm square. That is, we need to design for a M40 grade of the concrete. Okay, here what are the given data? We'll discuss one by one. First, it is grade of the design, that is M40. It is next a type of cement. It is PPC. Okay, OPC and PPC. OPC means ordinary Portland cement. Here it is a Barcelona Portland cement. It is okay. Next, a nominal size of aggregate is 20 mm. Okay, the maximum size. The aggregate size is for maximum is 40 mm. It is okay. Next, the IS 456 in table number 5, they given how the concrete should be exposed to the environmental conditions. It is severe conditions. Just I will show. Table number 5 of the IS 456. It is here. It is the export condition, that is mild, moderate, severe, very severe, extreme severe. How the concrete works. Based on this, they decide what will be the minimum composition of the cement. Okay, what is the minimum cement content as well as a water cement ratios based on a plain concrete as well as reinforced concrete. It is given by IS 456. Okay, using this one, for example, if it is M40, you can decide it for the water cement ratio of water cement ratio of 0.4. Okay, based on this also you can take the water cement ratio. Okay, next I will go back to IS code. Okay. Yeah, the condition is given. It is eager for reinforcement concrete. Workability, it is 75 mm. Here it is very important. For calculation of mixed design proportions, the workability is very important. It is given it for a 75 mm slump it is. And next, very important is the method of the concrete placing. It is a non-pumpable. It is Chute-Made method. Okay. It is non-pumpable. Okay, if it is pumpable means you have to reduce the a coarse aggregate by a 10%. If it is not pumpable means that whatever the calculations you are doing from the coarse aggregate calculations, that you can keep it as it is. Okay. Next, a degree of side control is good. Okay. Next, also very important is a type of aggregate. It is a crushed angular aggregate. Okay. And next we have sorry. Okay. Next we have a maximum cement content. Okay, not included fly ash, that is 450 kg per meter cube. Okay, this one is also I can obtain it from IS 456 minimum and maximum cement content. Okay, the maximum cement content is 450 kg per meter cube it is. Also, they used, very important is a chemical admixture, that is a superplasticizers. So the function of using superplasticizers is to reduce the water content, water cement ratios. Okay, here you can do the mix design based on using chemical admixture or without chemical admixtures. If you use the chemical admixtures means whatever the calculated water content you will get, you can reduce that up to 20 to 30%. If you are not using the water content or water cement ratio, you are keeping as it is and you are continuing the calculations. Okay. Next, material data they given. Here it is, cement, that is PPC. Okay, its specific gravity is given. Similarly, superplasticizers. Okay, next coarse aggregate, its specific gravity, and fine aggregate, its specific gravity. They're very important is given it as SSD. SSD is represent a saturated surface dry condition. It is. Okay, it is saturated, completely saturated, but surface is dry conditions. Okay, it is given the specific gravity of coarse aggregate and fine aggregate, and chemical admixture specific gravity is also given, and also a water absorption of the coarse aggregate is there. Coarse aggregate as well as fine aggregate. The coarse aggregate will absorb 0.5, whereas fine aggregate will be the 1%. Okay, this is also very important in the calculation part. If it is absorbing water means whatever the added water, that is whatever the water you got from the water cement ratio, that you need to make some correction for this ones. So if you are adding 100 liters of water, if it is absorbing a 0.5 and 1% of means you have to add extra water. That calculation part you will see at the end. Okay. The next is given a moisture content. Okay, already moisture is present in the aggregate means that again you need to go for corrections. Here it is nil, means there is a no moisture content before use of this aggregate into the concrete. Okay, and next data is very important is a C1 analysis of the coarse grade and fine grade. Okay, based on the coarse grade C1 analysis, you can classify the what type of gravel it is or what type of aggregate it is. Okay, in mixed design, the will not affect more, but in fine aggregate, based on the C1 analysis, we are going to make it as a different zones. Okay, the given fine aggregate it comes under zone 2 from the table number 9 of the IS 383. This IS 383 will give the different zones for it, different types of aggregates, or either it may be fine aggregate or it may be a coarse aggregate. Okay, for fine aggregate it is zone 2 from the table number 9 of the IS 383. This zone 2 is very important for our calculation. Okay, these are the given points or a given data for it. Next design, very important. Into a design procedure step by step by using IS 10262. Okay, this IS code is permissible in you can use in exams. Okay, you can take this hard copy into the exams. Okay, first step is to calculate a target strength for a mixed designs. Okay, in last class we discussed why this target strength is required. FCK is our characteristic strength, that is M40 you are going to design, but usually if anything happens, the strength should not become less than 40 Newton per mm square. That's why you are using a increase that style. That increase strength you are calling as a target. You are making the target of the strength. Okay, that is given by two equations. F dash ck is equal to fck plus 1.65s or f dash ck equal to fck plus xck. S is a standard deviation, x is the factors net on the concrete grade. Okay. Using these equations, S is okay. We'll go to table number 1. We see the value of S. So from the IS code, where is that table number 1? Yeah, here it is, table number 190. Okay. For what is the target strength of the concrete is M40. It is here, it is M40. What is the value of X? It is S6. Similarly, for standard deviations, our target strength is okay, our characteristic strength is 40, whereas standard deviation is 5. Put the value of X equal to 6.5 and a standard deviation of 5. Calculate the F dash CK, that is target strength. Here we will go to next design. Yeah. Okay, using this equation, 40 plus 1.65 is constant into 5. Okay, in table number 2, we got S equal to 2 for 40, that we got it as a 48.25. Okay, second equation, FCK plus 6.5, that is X is 6.5 for 40. Okay, we got it as a 46.5. So, higher value of these two equations we will taken it for a target strength. Higher will be the 48.25. This will be the our target strength. Okay, we need to design a concrete that is 1:2:3, whatever it is, whatever the next proportion comes, it is for a 48 newtons. Okay, if you prepare the cube of 150 mm dimensions, okay, if you compress for after 28 days of curing in a CTM machine, okay, the sun should be a minimum of 48 Newton per mm square, not less than. Okay, this will be your target strength. Okay. Next, table number 3 will give the air content. So some air proportions will be given. Okay, they given it for a 20 mm nominal aggregate. For 20 mm aggregate, we are taking it as a 1% of the air will be present in concrete. So taking it as a 1 cubic meter of concrete, in 1 cubic meter, a 1% of air content will be the there. Okay. Next, very important, we are going for a selection of water cement ratios. Okay, please see here. A selection of water cement ratio is based on either IS 456 from the table number 5 or by using that graph. Okay, we'll go to that graph. Our target strength is 48.25 is. Okay. Yeah, here it is. X-axis is water cement ratio and y-axis is compression strength. Okay. How much we got? We said that we discussed about this graph. The curve 1, curve 2, curve 3 are nothing but we are using. Okay, curve 1 is nothing but a 33 grade of OPC cement. Curve 2 is 43 grade of cement. Curve 3 is a 53 grade of cement. Okay, if you are using PP cements, you are using curve 2 is given. If you are using PPC or PSC or cement, you need to use curve 2 for the calculations. Okay, what is our target strength? 48. Okay, here it becomes 48. We draw a straight line. You see where that curve will cut that second curve. Here it is. Second curve. Second curve is for PPC purpose. Okay, and similarly we draw that straight line into the where it will cut the x-axis. Here it comes around 0.36. From this curve, we can obtain a water content, water cement ratios. We know the target strength, how much target strength is required. Okay, from this curve, we'll draw a straight line. Okay, we'll see that where the straight line will cut these curves. Okay, curve 1, curve 2, curve 3. If you are using OPC, you need to see what type of cement and what type of curve the calculations are for the required. So if you are using PP cements, only the second curve you need to observe. The second curve is at here. Okay, at 48. Here it comes. I will draw a straight line. I will see where it will cut. Means it will cut exactly. Again, I will draw a straight line. Okay, parallel to y-axis. I will see where that axis will be cut. Here it comes. Means the water cement ratio it will comes around between 0.35 to 0.4. By trial and error method, you can adjust that by taking it as a 0.6. Okay, this is very important. Okay, we go to calculation part. We got it as 0.36. Okay, but our IS 456 table number 5 will give me a maximum water cement ratio is 0.45. Okay, our obtained is 0.36. Maximum is 4.1, but our obtained is 0.36. Hence, it is okay. If you got it as more than 0.45 means again you have to revise these things. Okay, this is about a water cement ratio. This is very important. Okay, how to get a water cement ratio means by using graph. By using graph, you know the target strength. From the target strength, by using the different curves. Okay, if you are using PPC means that OPC 43 grade curve you are observing. So based on that observed curve, you are getting a water cement ratio as a 0.36 it is. Okay, next very important is a calculation of a water content. Okay, the table number 4 will give the water content for a different grade of the concrete. Okay, and for a different slump values. Okay, whatever the slump value is, we'll go to table number 4. Yeah, here it is. Table number 4. The maximum water content in terms of kg with respect to the nominal size of the aggregate. The nominal size, maximum size of aggregate you are using. The given data is 20 mm. The maximum 20 mm is in problem it is given. Okay, for 20 mm, how much quantity of water you need to add? 186 kg of water. Okay, this one is obtained. Okay, whatever the table in the table number 4 is given that value, it is obtained for a slump value of 50 mm. Okay. But our case in problem, the slump value is given it for a 75 mm. So the slump is changes means here it is given. Okay, for the desired workability other than 50 mm slump, the required water content may be increased or decreased by about 3% of the each increase or decrease of the 25 mm slump. Okay, if 20 if slump is 50 mm, directly you can use that value. If the slump is more than 50 mm or less than 50 mm, that you need to apply corrections. That corrections is you need to increase or decrease by 3% of the water. Okay, here our slump is 75 mm means a 25 more slump is recorded. Okay, hence how much quantity of water you need to increase means the 3% of water you need to increase. If it is 100 mm slump means you need to increase by 6%. Every 25 mm of slump you need to increase 3%. Other than 50 mm slump. Given is if the given slump is 100 mm means okay, it's more than 50 mm. How many times means 2 times of the 25 mm means you need to increase a 6% of the water content. So here is 75 means only 25 mm is increasing the slump. So we need to increase the water content of 3%. Okay, table number 4 are getting a 25 mm. Is 186 kg of water. Again, we need to increase 3% of water content because of the slump value is 75. Okay, the table number 4, whatever the calculated it is based on slump value of 50 mm. If it is more than 50 mm, we need to increase 3% of water for every 25 mm increase in the slump. So hence we increase the water content by 3%. So water content becomes 191.58 kg. Okay, this is the water content meter. In problem also it is given that are you going to use a super plasticizers. Okay, if you are using a super plasticizer means you need to decrease the water content. How much decrease the water content? It is based on a trial method. Usually if you are using for super plasticizers, okay, that one is also given In table number 4, okay, here it is. If you are using water reducing agent, okay, you can decrease it for 5 to 10%. If you are using a chemical admixtures, means you can decrease it from 20 to 30%. In between 20 to 30%, you can reduce. Okay, if you are using a chemical admixtures. Here in this problem, also you are using a chemical admixtures, hence the 1% of chemical admixtures you are going to use in the uh, trial mixes. Okay, usually the dosage will be the around 1 to 1.5%. Okay, this is in terms of dosage, but if you are using a if you are using a chemical admixture, means you need to decrease the water. So how much quantity of water can decrease, means here we are taking it as by trial and error method, right? That's a problem it is. Okay, based on trial method, we are going to reduce by 23%. 20 to 30%, you can take any values. Here we're taking it as 23% by the dosage of 1% by weight of the cement. Okay. Hence, the water content becomes 191.58 into 0.77. If it is 100%, means if you are not using any chemical admixture, means directly you can add this much quantity of water. But when you are using a chemical admixture, means the main purpose of chemical admixture is to reduce the water content. How much quantity of water you are reducing, means a 23% of water you are going to reduce. Okay, hence how much quantity of water you need to add? 100 minus 23 becomes 77. 77% is of the 191.58 that use water content we need to add. That becomes 147.52, or what I think as 148 kg of water you need to add into the mix proportions. Okay, the dosage is 1%. 1% by weight of the cement. Usually we take it as 1 to 1.5%. Okay, based on calculations, we got the water cement ratio as 0.36. Okay, 0.36 is nothing but water divided by cement equal to 0.36. In that, we know the quantity of water how much you are going to add. Okay, hence it becomes cement content becomes 148 divided by 0.36. It becomes 412 or 412 kg per meter. Okay. From IS 456 table number 5, the minimum cement content is given. This is given as a 320 kg per cubic meter. So minimum cement you need to add is 320 kg per meter cube, but you got it as 412. Hence it is okay. If you got less value, means again you have to revise this the water content. Okay, these are the dosage chemical admixtures. Okay, or you can change the next designs. Can make the number of trials actually. Okay, this is about a water cement ratios. From moving to next part, that is very important part. Again, we will get some confusion at here. Next, to calculate the volume of coarse aggregate and fine aggregates. Okay, table number 5 will give the volume of the coarse aggregate and fine aggregate. The both coarse aggregate and fine aggregate, that volume we are taking it as a 1. Okay, I will see that. I will use it. But I will go to the table number 5 and also zone 2. It is given. Okay, this table number 5. Okay, here it is. Table number 5. The nominal size is 20 mm. Okay, the zone of the coarse aggregate is zone 2. Here it is. No problem, it is going to have zone 2. Okay, hence the volume of the coarse aggregate becomes 0.62. Okay, whatever the calculations, the table they prepared by conducting number of trials for a water cement ratio of 0.5. Okay, they kept the water cement ratio 0.5 as a constant and they prepared these tables. Okay, if the water cement ratio is more than or less than 0.5, again you need to apply some corrections. That corrections we'll see at here. Okay, we'll go to again and examine that problem. Okay, for water cement ratio of 50.5, got it as a volume of aggregate is 0.62. Okay, the present water cement ratio is 0.36. Okay, the difference in the volume of coarse aggregate required increase or decreased the fine aggregate content. Okay, as the cement water cement ratio is lowered by 0.1, the proportion of the volume of the coarse aggregate is increased by 0.02, which is because of a rate of increase or decrease of the 0.01 of every point plus or minus 0.05 change in the water cement ratios. Okay. If you increase or decrease of the water cement ratio 0.05%, okay, then obviously again you need to decrease or increase by a volume of aggregate by 0.01%. Means the water cement ratio is 0.5 equal to 0.62. If the water cement ratio is 0.45, then this value becomes increase. If the water cement ratio is decreases, you need to increase the volume of the aggregate. Here, this one. You need to increase this one. If the water cement ratio is decreases. If the water cement ratio is increases, means you need to decrease the volume of aggregate. How much? How much increase or decrease? It is for 0.05 of the water cement ratio. Okay, increase or decrease. Now to increase or decrease of the 0.01% of the volume of the course. So we got a difference in 0.5 to 0.36. We got it as a 0.14. 1/4 we are decreasing the water content. So water cement ratio 0.14 water cement ratio are going to decrease. Hence, how much quantity of volume of coarse aggregate you need to increase means it is by 0.02. Okay, based on this table, you can add that is 0.36 equal to 0.62, that is from here, plus you need to increase 0.028. Why need to increase means decrease the water cement ratio. If you decrease the water cement ratio, you need to increase the volume of the coarse aggregate. If this one is increases means, that is water cement ratio is increases means, you need to decrease the volume of the aggregate. Hence, it becomes total volume becomes 0.648. Okay, this is the volume of the aggregate. Okay. In class, in given problem, it is given it as a non-pumpable. Here it is. So if it is non-pumpable means whatever the volume you got, you can keep it as. If it is pumpable means again you need to decrease this value by 10%. That's the difference between pumpable concrete and non-pumpable concrete. So here it is non-pumpable means we will keep this value as it is. Okay, this will be the whatever you calculated it is for a coarse aggregate. Coming to the fine aggregate equal to 1 minus whatever the coarse aggregate you have, that becomes our fine aggregate. Okay, 1 minus whatever the value you got from the coarse aggregate, that becomes fine aggregate. We are taking it as a 1 as a volume of the aggregate. Okay, moving to last but one step, that is next calculations. Okay. Some of these we calculated in terms of kg and some we calculated in terms of volume. Okay, all we calculate in terms of kgs. So that is next calculation. So whatever the mixed design, we are going for 1 cubic meter of the concrete it is. Okay. Taking the volume of concrete is 1 cubic meters. Okay. In part B, you taking as interrupted volume or interrupted air is 1%. 1% of the 1 cubic meter becomes 0.01. Next, you need to calculate volume of cement. So calculation of this one, volume how it calculated means mass of the cement divided by specific gravity into 1 divided by 1000. Okay, mass of the cement, how much you got? 412. Here it is. 412. Okay, 412 divided by specific gravity of cement. The specific gravity of cement is given in this next given problem. Okay, the specific gravity of cement it is 2.88. Okay, it is given. Okay, 2.88 into 1 divided by 1000. It becomes 0.143. In 1 cubic meter of concrete, 0.01 cubic meter of air will be present, and 0.143 cubic meter will be a cement content. By volume, we are calculating. Okay. Next, a volume of water. Mass of the water divided by specific gravity of water into 1 divided by 1000. Mass of the water is 148. Okay. After reducing the water content by adding super plasticizers, whatever the water content is on, that is 148 kg. Okay, that we are taking divided by the specific gravity of water is 1 into 1 divided by 1000, that has 0.148 cubic meter. Okay. Next is a volume of chemical admixtures. Okay. We discussed or added how much quantity of ore added means percentage in terms of 23%, but dosage is 1% by weight of the cementitious material. 1 to 1.5 you are taking. Yes. Normally you can't take it as 10%, 20%. Just 1 or 1.5 you need to take this one. 1% of the cementitious. Cementitious means here it is we are adding cement. Okay. The total weight of the cement we got it as 412, that is 402. Okay. 1% means it becomes 4.12. So it becomes mass of the chemical admixture divided by specific gravity of the admixtures. 4.12 divided by 1.145. The specific gravity of admixture is given. Okay. From this we got the volume as 0.0036 cubic meters. Next, volume of the all aggregate. We need to calculate volume of the aggregate. Okay. And total aggregate, that is total aggregate is 1 minus volume of air minus volume of cement minus volume of water minus volume of chemical admixture. That becomes volume of aggregate. Total aggregate. Taken it as 1 in 1 volume of air, okay, minus volume of cement minus volume of water minus volume of chemical admixtures. Okay. Calculate why you taking it as 1 means for 1 cubic meter we are calculating the mixed proportions. Okay, these are the calculated part. Okay. The remaining will be the aggregate. It is how much quantity of aggregate means 0.69 cubic meter. This is a total aggregate. It combines both coarse aggregate as well as a fine aggregate. Okay. Next we got in terms of volume. Next we need to get in terms of kg, how much kg of aggregate of presence. Okay, that we are calculating mass of the coarse aggregate is equal to, it is G. G means this value, whatever the coarse total volume you got as this one 0.695 into volume of the coarse aggregate into specific gravity of the coarse aggregate into 1000 degrees. So G means 0.69, whatever the total volume you got into volume of the coarse aggregate. But volume of coarse aggregate you got here. That is we discussed. Comparable and non-comparable here 0.68. Okay, this value are taken 0.648 into specific gravity of aggregate. It is given in this problem into 1000. So you get it as 1234.9 or general it as 1234. That is 1334 kg of coarse aggregate you need to add. The next mass of the fine aggregate, that is G into volume of the fine aggregate into specific gravity. G is here it is total volume, that is 6.695 into volume of the fine aggregate. Value of the fine aggregate here it is 0.352. This is taken as 0.352 into specific gravity is given in this problem 2.65 into 1000. We got it as a 648 kg of the fine aggregate. Okay. From this trial, this is very important. Okay, cement content how much you got? That is 412 kg per meter cube. Water you got it as 148 kgs. Okay, fine aggregate, that is SSP. Okay. Saturated surface dry conditions, that you got it as 648. For coarse aggregate it is 1234 kg per meter cube, and chemical admixture you got it as a 4.12 kg per meter cube, and free water cement ratio is 0.36. This is the first trial mix. Okay, this much quantity. If you are add a 412 kg of cement means these portions of water, fine aggregate, and coarse aggregate and chemical admixtures you need to add for a given water cement ratios. Okay, this is our answer. Okay. Next, very important is we need to adjust some water content, because in problem it is given some free moisture or absorbed moisture will be present. Okay, it is absorbed moisture. Okay, water absorptions and moisture content. Here the problem is moisture content is the aggregate will not absorb the water content, but sorry, it is not having any moisture content, but it is absorbing the water of this percentage, 0.5 and 1%. The absorb means the whatever you are going to add that water content. Here, how much water content you got? Around 1. Whatever the water you added, that is 148 kg per 1 cubic meter. 0.5% of the coarse aggregate and 1% of the aggregate will absorb this water. So the water available for the hydration process will be less. Hence, you need to apply some corrections after. You need to increase or decrease this water content. It is absorbing water content means you need to add some more quantity of water into the concrete. Okay, that percentage you need to calculate how much you need to add more water content. Okay, the condition it is given saturated surface dry conditions, that you have to calculate a dry conditions. The surface is dry but it is saturated, but totally dry means if you keep it in oven for 24 hours, whatever the absorbed water, that will also evaporate. So that way you need to calculate. Okay, I will the formula, that is mass of the aggregate, that is in SSB condition divided by 1 plus water absorption divided by 100. It is in terms of percentage, that you need to convert this numerical, that's why I'm making it as 100. So fine aggregate you got it as a 648 divided by 1 plus 1 divided by this portion means we got it as 642. This 42 is the dry weight you need to add. Okay, 648 is the saturated condition, 642 is dry weight. So difference between these two is 6 kg. 6 kg of water will be present in the fine aggregate, or you take the similarly you will take the coarse aggregate. Okay, mass of the coarse aggregate in SSB condition divided by 1 plus water, that is percentage of water absorbed. It's 1234 divided by 0.005. Okay, it becomes 1228, 1228 kg per meter cube. Okay. This is dry condition to add, this is a saturated conditions. Okay, if you are using a dry aggregates, just remember, if you are using surface dry aggregate, this quantity of aggregate you can add. If you are using dry aggregate means this weight, that is 1228, and here it is 642 kg of fine aggregate you need to add. But what about the water content? Let's say no. If you are using dry aggregate means it will absorb some water content. So how much quantity of water it will absorb? The difference you need to calculate. That is 6 kg here, it is 6 kg. Okay, 0.5 percentage of the this one, 1 percentage of the 640. Okay, that becomes 6 kg plus 6 kg. Okay, hence we need to add 148, that is the base water content, plus 6% is absorbed by the fine aggregate, that is 1% by weight of the coarse aggregate, fine aggregate. Okay, next 6%, 6 kg of water is absorbed by the coarse aggregate, that is 1228 kg of coarse aggregate. It is absorbed by 0.5% of the water, that becomes again 6. Okay, this, that is 12 kg of water extra you need to add. In 12 kg, 6 kg is absorbed by fine aggregate and 6 kg is absorbed by coarse aggregate. Hence it becomes 148 plus 6 means 160. So our final mix proportions, if it is in dry state, that is fine aggregate and coarse aggregate in dry state, the final mix proportions becomes, this is very important. Okay, the final absorption becomes, final mix proportions becomes, cement is 412 kg per meter cube, water you need to add is 160 kg per meter cube, and fine aggregate in dry state it is 642, coarse aggregate in dry state 1228 kg per meter cube. Chemical admixture is same, it is 4.12. The water cement ratio is 0.6. This is our final answer. This we need to calculate. For a 1 bag of cement, that is 50 kg, we need to divide all these things. So you can calculate these values with respect to 1 bag of cement, that is 50 kg of cement. Okay, whatever the water, fine aggregate, coarse aggregate, chemical admixture it is for a 412 kg. Okay, the same thing you calculated for 50 kg means just divide this value with respect to 50 kg. So you get in terms of 1 bag of cement. Okay, this will be our final answer. Just observe without correction, with correction of the moisture content. Cement will be the same. Water is 148 at here, it becomes 160. Why it increased 12 kg means here it is 6 plus 6 it increased. Why it is increased means the coarse aggregate and fine aggregate it absorb the water. Quantity of water absorption is 1% by fine aggregate and 0.5% by coarse aggregate. Okay, this is saturated conditions. Again we calculated a dry conditions, dry condition weight. Okay, this will be the mixed proportions. Okay, this is very important. In your final exam it will be asked for 15 marks or 20 marks questions. Okay, you can use this scorebook in exam hall. Okay, this is, if you have any doubts, please contact me. Okay, we'll stop at this point. Next class we will take the next examples.